In this lesson, we're going to talk about graphing simple rational functions. And so by the end of the lesson, you'll be able to define, graph, and apply rational functions with linear denominators. As we are going through this, you should be thinking about what's a rational function, how do I graph a rational function, and how can I apply graphs of rational functions to real data. We'll talk about 3 vocabulary terms, and that's rational function, hyperbola, and the branches of a hyperbola. So the first thing is, what is a rational function? So a rational function has the form f of x equals p of x over q of x. And this makes sense, right? Think back to when we talked about rational numbers and we said it's any number that can be expressed as a fraction. So our exception here is that q of x cannot equal 0 because we can't divide by 0. So q of x cannot be 0. So I could be talking about something as simple as 1 over x, and that's the graph that we're going to look at first. But I also could be talking about something that looks like x plus 1 over 2x minus 4. The only thing is that in this section, we're only looking at linear denominators. So you won't see a denominator in this section that's like an x squared or an x to the 4th power. Only linear denominators. The graph of these kinds of functions is called a hyperbola, and we'll talk about what that looks like and what its characteristics are. And if we're just talking about that graph of y equals 1 over x without any kind of transformations, it has the following characteristics, and these are right on your notes. The x-axis is a horizontal asymptote, and the y-axis is a vertical asymptote. Also, the domain and the range are both all non-zero real numbers, and that's again until we start to do some transformations. And the graph has 2 symmetrical parts, and those 2 parts are called branches. Also, for each point x comma y on one branch, there is a corresponding point that is negative x, negative y on the other branch. And so we'll look at what that looks like and how knowing that makes it easier to fill in some blanks as you're trying to do this from scratch. The first one that we want to do, though, is just that basic graph of y equals 1 over x. So let's start out with the positives. So if I plugged in 4 for x, y would be equal to 1/4, 3 would be 1/3, 2 would be 1/2, 1 would be 1, and then 1/2, if I do 1 divided by 1/2 to get a y, my y value would be 2. So now what I want to do is just plot those points. This is what we've been doing as we're doing graphs of exponential functions and logarithmic functions. So I want to plot 4 1/4, and 3 1/3, 2 1/2, 1 1, and then 1/2 2. From the last slide, we know that we have a horizontal asymptote at the x-axis, and we have a vertical asymptote at the y-axis. And what I want to do now is just connect those points approaching my horizontal and vertical asymptotes. And there's the positive branch, the positive hyperbola of this function. And now, from what we talked about on the previous slide, for any value x comma y on one branch, I should have the same corresponding value, but negative x comma negative y on the other branch. So if I put in -4, I should get out negative 1/4. And that works too with this math if you just do the math. If you say y equals 1 over -4, negative 1/4. -3, I'd get out negative 1/3. -2, negative 1/2, negative 1, negative 1, and negative 1/2. I should get out negative 2. And now I want to plot these points. So negative 1, 2, 3, 4, negative 1/4, 1/3, negative 1/2, negative 1, and negative 1/2, comma 2. And same thing, I want to connect these points so that they approach my vertical and horizontal asymptote. And there's my graph of the function y equals 1 over x. Next, we're going to look at some transformations. So in general, and now we're adding in an h value and a k value. So functions that have the form y equals a over x minus h plus k have asymptotes at x equals h and y equals k. And so the domain of this kind of function is going to be all real numbers except h. And the range will be all real numbers except k. So let's look at a more specific example where we actually graph it on the next slide. So we have y equals negative 2 over x plus 3 plus 1. So we want to graph it and state the domain and the range. Now remember with our h values, this is x minus h. So that would actually be a shift of 3 to the left. And that means that I have an asymptote at x equals negative 3. So I'm going to draw that in. And then I have another asymptote at y equals 1. So I will draw that in. And now I want to find some points that will work to plot. So I want to start, and it really doesn't matter, but I'm going to start with the branch that is going to be, or the hyperbola that's going to be over here. And I just want a couple of points that will work out conveniently to plot. So, for example, if I chose negative 1 for an x value, if I do this math, I would have negative 2 over negative 1 plus 3 plus 1. And so I would get out negative 2 over 2 plus 1, or negative 1 plus 1 is just 0. So the point negative 1, 0 should be on my graph. And then if I plugged 1 in, I should get out 1/2. And so the point 1 comma 1/2 should be on my graph. And if I have 2 points, that's really enough information for me to draw in, and I should not do that in the same color as the asymptote, for me to draw in what the general shape of that graph would be. And that was the other point, 1, 1/2, and down this way. Okay, and now I want to do the same thing on the other side. And so I want to pick a couple of convenient values for x. So for example, if I plug negative 4 into this equation, I would get out 3. And if I plugged in negative 5, I would get out 2. And so that's enough there for me to plot negative 4 starting from the origin, comma 3, and negative 5, 2. And so again, that's enough information for me to sketch what this graph should look like. And so now, if I am answering this question about the domain and the range, the domain of this function should be all real numbers except for negative 3, and the range should be all real numbers except 1. So that's a basic overview of graphing, and then when we're in class tomorrow, we'll talk about a couple of more complex examples of transformations, and your practice problems should be on your notes.